Welcome back to my class. In this video, we are asked to solve this first order differential equation using perturbation method, okay? Regular perturbation method. It's a very simple question. The first thing to do is the right solution. Now, if you remember power series solution, you will now remember the formula for perturbation. For power series solution, we have that y is equal to what? The summation of n starting from 0 to infinity of a n, then s raised to power n, okay? That is for binomial. That is what is it called? Power series expansion. But for perturbation, the difference is that you are going to replace your a here with y, and then replace your x here with epsilon. That is just the difference. So the equation here should be the solution. We assume that the solution to the above differential equation is y is equal to the summation of n starting from 0 to infinity of I said we are going to have epsilon raised to power n, then y subscript n. So if you do this, you see that when n is 0, we are going to have n raised to power 0 is 1. So I'm left with just y0 plus when n is 1, I'm going to left epsilon y1, then plus epsilon squared y2 plus dot dot dot. That is how it continues. But if you look at this, see that this is first order differential equation. So we are interested in the first. So from here and above, they tend to 0. So all this place is gone. So I'm left that my y should just be equal to y naught plus epsilon y prime. If we can get the value of y naught and get the value of y prime, then we have gotten the general solution. Then to get the particular solution is now to put our boundary problem as simple as our boundary conditions, as simple as that. So what do we do now? The next thing to do is, if you have gotten y, we have gotten y now. So we need to get y prime so that we can substitute in this equation. So for me to get y prime, let me write it here. Y prime will now be equal to, differentiate this one, you're going to have y prime naught plus differentiate this one, you're going to have epsilon y prime 1. Okay, so to substitute in this equation, let me call this equation 1 and call this equation 2. To substitute in this equation, or let me call this equation 2 and call this equation 3, and then call the main equation 1. Okay, so I will say substitute equation 2 and equation 3 inside equation what? Equation 1. So I'm going to have 1 plus epsilon multiplied by y prime, and this is my y prime. My y prime is y prime of 0 plus epsilon y prime of 1. Okay, then plus my y. My y is this one, which is y of 0 plus epsilon y1, and is equal to 0. So the next thing you do is to open the bracket. If I open the bracket, 1 times this will give you y naught prime. 1 times this will give you epsilon y prime 1 plus epsilon times this will give you epsilon y prime naught plus epsilon times this will give you epsilon squared y prime 1. Okay, then plus y naught plus epsilon y1 is equal to 0. So the next thing we are going to do here is to compare the left hand side with the right hand side. But before that, we're going to have that this is epsilon squared y prime 1 plus those that have only epsilon is y1 prime plus y1 naught plus y1. All of them has epsilon in common. Then those that does not have epsilon, which is what? Y prime naught plus y naught is equal to 0. Okay, see the way I arrange it. So now, let us compare by the power of the epsilon. So we're going to see that here, epsilon squared y prime is going to give us 0 because there is nobody here. But if you look at it, this is the first order. So we're interested in the first order as well. The same thing applicable to here. So we're interested in epsilon being raised to power 1. We're not interested in raised to power 2. So that means from here we're going to have that our y prime 1 plus our y prime naught plus our y1, okay, epsilon should be equal to, there's no epsilon here, so we have 0 epsilon. So epsilon taking care of epsilon, we have that our y prime 1 plus our y prime naught plus our y1 is equal to what? 0. I can call this equation equation 4, right? Equation 4. And then let's go to those that does not have epsilon at all, which is what? Our y1 naught plus our y naught is equal to 0. And if you look at this very well, you see that this is first order differential equation. So I'm going to have, sorry, is that? Yes, first order differential equation. So don't forget that the main aim is we need to get our, this is the main equation. So we need to get our y naught and y1. So we can get our y naught here. So this is going to be dy naught over dy, over the x, okay? Then plus y naught is equal to 0. Collect like terms to have that dy naught over the x is equal to minus y naught, okay? Or rather, let me do it this way. Sorry. Permit me to do it this way. That y prime naught will now be equal to minus y naught. And this thing means dy dx. So dy dx naught is equal to what? Minus y naught. Now separate. This is variable separable. So I'm going to have dy naught over y naught is equal to minus dx. So if I integrate both sides, I'm going to have the integral of 1 over y naught, the y naught will now be the integral of minus dx. So if you integrate 1 over y, I'm going to have ln y naught is equal to the integration of this to give you minus x plus a constant. So if ln goes to the other side, it becomes exponential. Or if you take the exponential of both sides, you're going to have that y naught will now be exponential minus x plus c, which is something as y naught is equal to exponential minus x multiplied by exponential c. And the exponential of a constant is a constant. So y naught will now be what? A exponential minus x. So I've gotten my y naught. So the next thing I'm going to get is my y1. Then we substitute in the question. So permit me to clean here. Okay? So from equation 4, and equation 4 said y prime 1 plus y naught prime plus y1 is equal to 0. Okay? And then we have gotten that our y prime naught is something as minus y. So let us put it. Y prime 1 minus what? Y naught, because this is something as minus y naught. Then plus y1 is equal to 0. So let me collect like terms. Y prime 1 plus y1 is equal to what? Y naught. And I have gotten my y naught to be the same thing as a exponential minus x. So let me now substitute it there. If I substitute, I'm going to be having that y prime 1 plus y1 is equal to what? A exponential minus x. Now this is linear equation, first order linear equation. So, and first order linear equation is given by y prime plus p of x y plus is equal to q of x. So if I put 1 here and compare the two of them, I'm going to say that my p of x is equal to the coefficient of the y1, which is 1 here in this case. And then my q of x will now be anything at the right hand side, which is a exponential minus x. So the next thing to get is your integrating factor. My integrating factor is equal to what? Exponential the integral of p of x dx, which is equal to what? Exponential the integral of 1 dx, which is what? Exponential x. So now my answer will now be y1 multiplied by that integrating factor is equal to the integral of q of x multiplied by the same integrating factor dx, which will give you y1 multiplied by exponential x is equal to the integral of exponential, the integral my q of x is a exponential minus x. So multiply by integrating factor exponential x dx. So if we continue, we are going to be having that. Our y1 exponential x will now be equal to, now this and this is taking care of each other. So I'm having the integral of a. That is the integral of a dx. So this is something as y1 exponential x is equal to what? The integral of this will give you ax plus a constant. Let me say the constant is going to be b, for instance. Anything that is a constant is a constant. So we're going to have that our y1 will now be divide everybody by exponential x. So I'm going to have ax exponential minus x plus b exponential minus x. So that is my y1. So what our general solution becomes that y is equal to what? Y naught plus epsilon y1. Okay, so which is now our y naught gave us a exponential minus x plus epsilon into our y1 gave us ax exponential minus x plus b exponential minus x. So if I now put our boundary problem, this is our general solution. So for the particular solution, they say that y of 0 is equal to 1. That means when y is 1, our x is 0. So if I put it here now, I will now have that 1 is equal to a exponential minus 0 plus epsilon in bracket of a of 0 exponential minus 0 plus b exponential minus 0. So if you look at this, you see that here is 0 and anything raised to power 0 is 1. So in this case, I'm left that 1 is equal to what? A plus epsilon b. Because everything here is 0 and I'm left with b. B times this will give you epsilon b. Now, if you remember, they say that epsilon is small. Epsilon can be neglected. So epsilon will make us to assume that b will not be equal to 0. And if b is 0, automatically our a will not be 1. So you now come back and put it in your distance to get your particular solution, which is what? Y prime is equal to what? My a is 1. So I'm going to have x exponential minus x. Sorry, where is my y? Okay, this is my y. Sorry. This is my y. So my y now will now be what? A, which is 1. So I'm having exponential minus x here plus epsilon in bracket of my a is 1. So I'm having x exponential minus x plus my b is 0. So everything here is 0. So my final answer is now that y is equal to exponential minus x plus epsilon x exponential minus x. So that is the result. So thank you very much for watching. Some can write their own as y is equal to, they have exponential minus x as common. So I have 1 plus epsilon x, all bracket exponential minus x. So this can as well be the answer. So thank you very much for watching. Please don't forget to like our video, share and subscribe and then turn on the notification bell so that YouTube will always recommend our videos for you. May the peace of the Lord be with you. Bye.